it's time to test your communication and storytelling skills. So we have a game for you, and we have prepared some data science term, and we hope that you can briefly explain the terms in layman terms, so our audience, even they don't understand data science or even math, can understand the term. So are you ready for the game?
Yeah, bring it on. Hope I can explain these terms.
Okay, the first one.
Right, training versus test data. Got it. Cool. I think for this, this is mainly more on the machine learning models training part, and in a very layman terms, I think it is like you need to spare some data to train your model. Basically, you need to let your model learn the pattern in your data. How to learn it? You need to give some data for the model to learn, right? But usually in the data set itself, we need to split the data into certain ratio. I think that there's no optimum ratio here. Could be 7:3, could be 8:2. But I think the rule of thumb in the industry is either 7:3 or 8:2. So usually how we split the train test data is maybe, for example, you split 80% of the data that you have, and you use this 80% of the data and to train your model. So now once your model has learned the pattern, right, the pattern in your data, what exactly it is, and then you can use the remaining 20% of the data to test how well your model has learned. Right, I think this is the main function of the train test data here. Yeah.
Then decision tree.
Decision tree. Nice. Actually, this is the first the model that I learned back in my overseas internship there. I didn't know much about that, but I think in a very broad term, decision tree, if else kind of tree. So imagine the decision tree is like a whole tree here, but then you can break it down into different criteria, different conditions. If this value is bigger than 1, then I'll split it this way. If the value is lower than 1, then I'll split it this way. So essentially, decision tree is a list of conditions in a hierarchical format from top to bottom here to help you split the data. And this is how they learn the rule. So decision tree is a very simple model to learn the pattern based on the rules that they create. And then when you feed in the data into this model, it will tell you whether it is true or false, or whether the regression, right, to predict some value based on the rules that they learn. So I think the conditions here in the decision tree highly depends on the data that you feed in, the features that you feed in, and then that determines what kind of pattern that they learn. So back again, we are talking about the learning pattern, right? Essentially, the machine learning models is all about learning pattern. Yeah.
Right.
And here we are talking about the rule-based pattern here.
Okay. This one, NLP.
NLP, yeah. NLP is I think it comes back to I think this is the field that I'm highly interested in. It comes back to the text analysis parts, where just imagine right now you are using WhatsApp, you're using Twitter, you're using Facebook Messenger, you are browsing your internet, looking some articles. All these are words, and there must be some models that can be used to analyze these words, these texts, right? So this is where the usage of NLP comes in, whereby we use some of the NLP's models to kind of get some insights based on the data, the words that we feed in. For example, sentiment analysis is one of the common usage of NLP to decide whether the sentence that we feed in is positive or negative, whether there's any anger within this sentiment, whether there's any happiness within this this sentence. So I think NLP here is really the future, right? Because if you look at the Google Home, what Amazon has been doing using the Alexa, all this requires intense usage of NLP to train the model for a very, very long time to really learn the pattern itself, because you need to use the model to construct a sentence or construct anything, but that requires sequence. So to do this sequencer, you need to have a very complex models behind here. Yeah. So this is how I see it. It can be widely used in any industries out there.
Last one.
Yeah.
Neural network.
Wow, neural networks. Cool. Right, I think this goes back to the very fundamental truth would be calculus. If you break it down to the very basic level, actually neural network is nothing but a formula, a list of formula where you train every single neuron to get the optimum parameters here. Remember, when we talk about the common machine learning models, we just train one model. But now in the neural network itself, because each of the neuron have their specific optimum parameters, so we need to feed in the model, train every single neuron to get the optimum parameters so that they learn the best learning pattern. Now, at this point, some people might ask, so what's the difference between common machine learning models compared to neural network? I would say that neural network, because they have so many neurons in different layers, it is able to learn a deeper level of pattern that you would not otherwise see. So if you have like image, so many pixels out there, they need to figure out what exactly each of these pixels means. And this is what the neuron does, right? Because you fill in, they can just identify the color, the pixel, the RGB, what that means, and then they figure out whether this picture is what you expected, right? So I think this is the whole idea of neural network. Of course, we can talk more about each of these layers itself, but this is the idea in general, yeah.
So we talk about a lot of like data science term and algorithm. Admond, the natural question is, do you have a favorite algorithm?
What algorithm? Sorry, favorite algorithm to. Algorithm. Yeah, XGBoost. If you were to ask me, XGBoost algorithm is a boosted decision tree. And what I love about it, because XGBoost can be used in both classification and regression, and it's easy to train, and you don't require a lot of data to fit into neural network. I wouldn't go into neural network unless I need to, I have to, I'm forced to do it. I always go with the simplest model first. In this case, the simplest one and the most robust and versatile one would be the XGBoost model. Easy to train, open libraries out there with Python or R. And here's the challenge. XGBoost here is highly sensitive for tuning. So the feature that we feed into that must be a very good feature. Otherwise, it can't learn some useful pattern here. So before I use this model, usually I will make sure I will have a list of good features.
Right.
And I feed in the model and learn from it. Yeah. It's very fast. It's optimized to run with a huge load of data. The most interesting thing that I've encountered in my current job or throughout my career?
In your current job.
In my current job.
To you,
I think in my current job would be, I got a chance to write a production code, because to me it's a privilege that I don't just give a POC, but I got a chance to productionize the code, and that helps me a lot in terms of the software engineering skills. What are the best practices? What should we do before we write the code out there? Because I think, at least to me, when I write a bigger model, the code is always messy. When you show to any software developer, they will look at your code, they will say, this is so messy, it doesn't align to any best practices in the market, right? So when I was doing the production code development, I learned a lot from my team members, how to do it in a good way, how to do the Git stuff, Git flow. What should we do? How we can work together through Git, and all these stress test cases. How can we build test cases that can reduce the deployment phase? So all these are something that I found it's very valuable to me throughout my career, that I learned a lot from it, yeah, as a data scientist, because it is not easy to deploy it, and I think we seldom have the chance to deploy it. Usually what we do is more on the POC phase, then we let other people to do it. But here, I was very fortunate to get a chance to do it and learn a lot from it. Yeah. Great question. I think one of the great ways to do it is just go to whatever libraries that you're using now. Let's say Pandas in Python. Pandas is open source library. So go to the GitHub library, go to the GitHub source of Pandas, look at the code in the library. So those are the best practice codes. Those are the productionized code out there that have been developed by so many people, not just data scientists, but the very good programmers, right? The developers, they work together, put up the code, optimize the code. I think we can learn a lot from that when we want to learn the productionized code, right? So this is how I will learn, yeah.
You convince your top management to do data science project? What is your secret here?
I think, to be honest, I haven't done this before because usually the projects are brought in to us after so many discussions with upper management, right? But we do have this workflow where we propose our data science projects to upper management, and then once they agree, then we start doing other stuff, right? So to me, what I've seen so far is that what exactly, again, your problem statement, what are you solving? Is that relevant to what people are looking for? What other engineers are looking for, right? And what is the outcome? What is the expected outcome that you foresee, right? It is not just about a higher accuracy, but what is the KPI? How you can help them in the factory, right? 99% accuracy of model doesn't mean anything if the people don't act on it. So what are the results that can motivate people to do it, and what is the impact? How much money can they save, right? So problem statement, the method parts, and then the expected outcome. What is the ROI, the KPI? How much money that you can save, or how much money that you can earn? I think these are the key things that we can try to put in when we try to propose our ideas or data science projects before getting approval. Yeah.
What is the AI culture in Singapore? Does the government in Singapore support AI, or what does it look like in Singapore?
Yeah, I would say the government here in Singapore is super supportive, and they even have a vision called Smart Nation. So Smart Nation here is meant to become a country where the digital economy is there. So everything must be either online or must be automated. So they really put a lot of effort, funding, or even programs, competitions to encourage not just students or even companies or startups to get more innovative ideas, implementing what can do more in terms of, say, e-payment, or in terms of transportation, Grab in Singapore, or e-commerce, Shopee, and all these things. Or even right now, if you have heard the news, recently Alibaba, they are going to build one of their largest headquarters here in Singapore, and they brought the whole tower, the AXA Tower in Singapore here to build their tech team. So I think this is why the government is trying to get more and more MNC companies to really come in, invest in their country, and in a way to build more talent and to build more capabilities in future for Singapore. Yeah, so they are very supportive of this, and a lot of meetups, programs, university programs, competitions organized by Shopee, other people, other companies out there. So there's a lot of, I would say there are a lot of opportunities here, and so many tech startups are booming, and a lot of students are getting more and more interested in this field once they start learning more and more about this field. And even there are so many, I think one of the key things that the government is trying to do is they give courses by subsidy. So imagine you have an online course out there, someone published it, someone is selling it, some companies are selling it, and the government would likely to subsidize it up to 90%.
Wow.
So the people here just need to pay like 10%, which is nothing from them. So more and more people would tend to, enroll in this course and learn about this stuff, right? Yeah.
Citizen in Singapore, do they aware the use of AI in the city? Like, how much do they understand data science in general?
In general, I think let's talk about the younger population, right? I think when we talk about this, the awareness, at least now, is higher because I can see more and more educational institutes, universities, and also external courses out there. They are offering all these kind of different data science courses so that more and more people get to enroll. and more and more people are more aware of these kind of applications of data science in their day-to-day life. So if you just look at Netflix, Grab, even some of the ads that you see on Instagram, Facebook, all these are being run by models behind, and people are really aware of this. But maybe they are not aware of the technical stuff behind, but they know that all these are driven by what we call models or AI applications behind. I would say the awareness here is increasing. It's trying to catch up. I think it's doing a great job here. Government, educational institutes, and even external institutes, they are offering these kind of courses because they want to catch the wave. So many people are interested. They can't learn it in school. Now they come out of school in a mid-career path, and they want to learn about data science. How? Either you go to master or you learn from other courses offered by other companies, right? So a lot of companies are doing this.
So like in Hong Kong, we have a lot of data science related course in the university as well. So we have data science, we have computer science, we have statistics. So Admond, in your point of view, would you recommend people to take computer science or statistics or data science? What is your take?
Wow, it's a good question. Statistics, computer science, or data science? I think they are all interlinked to each other. But if a person wants to go into the really the algorithm side of the coding part, programming part, like the algorithm, the tree, all these things, I think computer science might be a suitable path, because in the future, the person can change the path to data science anytime, because you already got a strong foundation in programming and understanding of the algorithm, right? But if the person wants to go into data science, like in the short term, want to understand more about the broad picture, then yes, data science, right? But either way, I think statistics, computer science, in the end, I see a lot of people here, they are from comp science or they are from statistics, graduated from master programs, and they are now doing data science work. So it wouldn't take a lot of effort or time for them to change to data science field, because they already have the background, unless they are from psychology background, or unless they are from, I don't know, some very non-related background, then yeah, it's a bit tough, but it is possible. Definitely possible, yeah.
Do you think there's a benefit in holding a data science degree compared to other like traditional like computer science or statistics degree when you like apply for a job in Singapore?
I think, to me, right now what I'm seeing is this data science program or certificates are still quite young. So it's not really like widely recognized, because they just came out from like 1 or 2 years ago, right, after the golden period started. And I think having a master degree or data science related degree is optional. It's optional. And to me, back to the point that I believe that having a great portfolio is more important than having a relevant program. I'm not saying the program is not important, but if you graduate from this program, and if all your portfolio are just about doing the assignments, the final year project, or whatever things they are taught in school, again, you are the same as your peers who graduated from the same program like you, and you come out to the workforce, look for a job with the same portfolio. Doesn't make any difference. You get me? So so I think the portfolio part must be something very special, very personal, and it's just you, right? It's just you, it's just your portfolio. There's a lot of portfolio. Wow, this guy done this before, this guy's done that before.
As a data scientist myself, what I'm interested is, do you think like finding a job in Singapore and Malaysia is easy? Like, do you think there are a lot of opportunities now in Singapore?
You mean during the COVID period? Or after the COVID period? Yeah, I think right now because of the COVID, right, the virus, a lot of our companies, not just Singapore but also Malaysia, are facing some unemployment difficulties. A lot of people, even fresh grad or mid-careers, they got retrenched because of this virus, especially from the airline industry, from the F&B industry, tourism industry. So if you just ignore the COVID parts in general, without the COVID, I think a lot of tech companies in Singapore are hiring. Even now during the COVID period, I still see a lot of tech companies, they are hiring. For example, Shopee. But some of them, they already freeze the headcount because of the uncertainties ahead. But some of them, they are still hiring. And I think part of it is because for tech companies, you don't really need to go to the office to work. It's all about work from home. If you look at the recent news right now, Twitter, Facebook, Google, they are all launching like work from home, right, for the rest of the year. Yeah, so I think the opportunities here for data scientists are abundant. Just go to LinkedIn, type data scientist, look for Singapore, and you still can see a whole list of job openings here, you know. And that's what I love being in this field. There are always different opportunities. And as a data scientist, we are not stuck or locked to a certain industry, right? Because our skills are highly transferable, either technical skills, models building, or soft skills, right? If you don't want to go to this industry, maybe next day you want to move to logistics industry, cool, go there. You still have your skills, right? Technical, soft skills. Just that you need to learn the domain knowledge.
Yeah. Right.
Yeah.
So I think being a data scientist is not easy, right? Because we basically have to learn a lot of things, and those things change a lot, like every day. So what motivates you to become a data scientist, and like what motivates you to go on?
Yeah, it's hard, man. I feel you because it's not just the models, even the platforms, the tools that we are using, right? The database, the language, all these things are changing. Not every single day, but maybe a few weeks later on, then it comes a new stuff, right? I think what really motivates me is the community that I'm in now, especially on LinkedIn. I'm very active on LinkedIn. I always talk with people in this field. Most of the latest news, the latest update, the latest technology that's in the market right now, I learn from others on LinkedIn. Like really, I don't really read articles every day, but when I read the posts, some of the data scientists out there, they might post, you know, now fast.ai just launched a new library, or Google just launched a new TensorFlow, I don't know, 3.0. That is where I started learning the new tool, right? I started learning more and more from others. What do you think about this tool? What is the pros and cons? And seeing all these people are so passionate about what they are doing really motivate me to push myself harder, you know, down the road. And this is what I like about the data science community here on LinkedIn. And I really appreciate it because this is the platform where I got started in data science in the first place. Yeah. I hope I'm a successful data scientist, not because there's so much to learn, but what I'm aiming to become, right? To become a successful data scientist, to me, based on my understanding, is we really need to be good at the technical and the soft skills. And when we talk about technical, it's not just about building model, but really to gain a good idea of the full pipeline. To me, I don't think you need to know every single thing, but at least you need to know what you need to do from the beginning to the end, from understanding the problem, getting the data in, the data pipeline, the data loading, engineering part, how you're going to transform the data into a usable format, how you ingest the data into database, how you get the data from the database, crunch the data, clean the data, book the model, and all the way until the visualization parts. And this visualization part can be on any platforms like Tableau, like just simple Matplotlib, you know, this language, or maybe Dash, stuff like that. So that depends. So but I think in general, we need to understand these different kind of aspects all the way to the deployment. Yeah, the deployment part is a bit tricky, but once we start doing this, then we get a hang of it, how we should deploy in sustainable formats, you know, how to deploy in a large scale, PySpark, Scala, all these things. So to me, what I'm aiming to do right now, the phase where I'm in is I try to become a generalist data scientist. I wrote one of these articles on Medium because I think it's quite interesting to talk about. So what I mean by being a generalist is you don't need to be very great at something first at the beginning, but you need to know something in everything.
Right.
Right. Once you know something in everything, now you know, maybe after some time, you know which exactly the vertical that you want to specialize in. For example, I want to specialize in NLP, right? So this is the thing that I want to specialize in. So I focus on NLP alone, while I already have the big picture of what it's gonna take, right? Things like that, the pipeline, how to deploy, and this is what I focus on. And this is what I would say as a specialist data scientist. So these are the two phases that I personally see that, you know, and ultimately what I aim to become is a specialist data scientist to focus on one particular vertical, in this case NLP, the text analytics part, things like that. Yeah. Why? Because first, it's quite interesting to analyze the text, play around with it, get some meaning out of the sentences alone. The second thing is, I believe that in the future, more and more text will be coming along, right? Social media, tons of billions of text, posts, status, Twitter, you know, all this stuff. And more people will need to harness the power of NLP to make sense of the data that they are getting. So I'm still in the generalist phase because I'm still quite young in this field, to be honest, but I'm trying to, you know, get a better picture of everything. And when I move into the second phase to focus on one particular thing, now I know what to do. Right now I know what to focus on and things like that. And to become a successful data scientist, I think these are the two phases that a data scientist has to go through. And of course, soft skills part. Yeah, right. So these two phases require the soft skills, right? Again, the communication skills, how you tell the stories, things like that, how you work with other people. I think these are quite important things, you know, to have. And we can do nothing but really to just learn along the way. Yeah, just learn.
Domain expertise, we have math and statistics, we have machine learning and deep learning, we have coding, and we have communication. So how do you rate yourself and why do you rate yourself?
On the scale from 1 to 10?
Yeah.
Is that what you're saying?
Yeah.
I think to me, domain expertise is something that I'm still sometimes struggling with. To understand the business is quite tough, to be honest. So many things to learn, so many terms that I don't understand yet sometimes. So I will rate myself 1 to 10. I will rate myself as 6 for now. 6, right? 6 for now. And the programming skills, I will rate myself, just Python, just talking about Python, right? I will rate myself at 8, around that, 8 or 7. Machine learning or deep learning, I would say 7 or 6. Yeah, because I'm not very specifically a sophisticated or technical person. If you ask me to build a model from scratch, I can't do it. But if you ask me to know which library to look for to solve a problem, yeah, I know how to do it. This is how I solve a problem. And the third thing is the math and statistics part. I would say 8. Yeah, because physics gave me quite a good foundation on it, and now I'm still learning on it. So 8. And then the last one is the communication parts. Yeah. I think about 8 as well. Yeah. about 8 or yeah, 8 or 7. Still a lot to learn. Like when I speak to especially non-technical people, sometimes I also, I try to get some feedback from them, right, in the past during some of my other meetups and workshops. And some of them also kind of struggle to understand, the terms I use, the explanation that I did. And every single after these meetups or workshop, I try to see what I can improve in terms of how I can frame this as a flow story that people can relate to. So I try my best to relate what I'm saying to them so that they know, oh, I feel you, man, I feel you. Okay, it's good. Yeah, try. But still trying, still learning.
So do you have a favorite quote in your life?
Favorite quote? Yeah. In fact, I have one hanging on my wall now. I think short and sweet. The quote is that I'm using now. If not now, when? Short,
right.
4 words. If not now, when? And I think this really resonates with me because I think it really struggles. Wait, how about it? Okay, it really struggles when I kind of tend to procrastinate sometimes. But whenever I have this kind of tendency, I look at a quote, then I need to do, man. I need to get back to work and take actions and just do it. Because I think the motivation part comes from doing. So the more I do, the more motivated I feel. I don't feel like writing articles sometimes, but when I start writing, I have the motivation to continue writing. So that's how I see it. I just need to start writing, start doing, then the motivation will come and continue the rest. Oh yeah, by the way, I think having a growth mindset would help as a data scientist as well. Yeah, growth mindset to keep learning. And yeah, too much things to learn. Sometimes you might feel a bit overwhelmed, right? Do you feel that, it's too many things to learn? Okay. It's a new tool. Should I learn TensorFlow or Keras? Should I learn PyTorch to build a model? Yeah, what should I learn, right?
Thank you so much, Admond. Thank you for your time. So before we end this video, do you have any key message to our audience? And
okay, 2 things. So the key message here is really for those who want to go into this field or just want to learn more about this field. I would strongly encourage you to really explore more by networking, reading articles, getting to know more people, and just ask them, right? Just feel free to ask them. Don't be afraid to approach them and ask them questions to know more about it. So this is the first one. And for me, if you can approach me to know more about me, you can always visit my website or LinkedIn profile. These 2 main platforms. Yeah, my website is just admondlee.com, and LinkedIn you can just find me by typing my name in there. So feel free to connect with me. I look forward to sharing and learning from you guys soon. Yeah.
Sure. Thank you, Admond. Good luck with your work. Thank you so much for your time, and we'll see you next time.
Sure. Thanks for the time, Claire and Leo. Yeah, thanks. Really excited to be invited here. Yeah. All the best, and talk to you guys soon.
想了解更多，記得 like 我哋條片同埋 subscribe 我哋嘅 channel 啦。